Hi, my name is Nathan Thomas-Benke, and this is my L Systems visualizer, which I created in Unity. So to start off, we just hit the play button within the Unity project, and it will load the preset for tree A, which is equivalent to the A tree that was in the description of the assignment, which had the iteration level of 5, an angle of 25.7, and then these input values for the axiom and rules, which I translated to the notation or to a notation that works within this program. So by simply hitting the regenerate tree button, it will load the tree in question uh, that was pictured for the assignment. And just as simply as you were able to generate the tree, you are able to iterate by using the slider. I decided to use sliders instead of using hotkeys on a keyboard, simply because I thought it would cause uh, buffering issues, and for some of these other examples within the GUI, I just want to keep everything consistent. So let's go down to the first iteration. I think the generator, see that it generates all the way down here at the bottom. So you can kind of see whenever I drag my mouse that the speed is kind of far. So all we want to do is lower the drag speed so that we're not kind of flying off into the distance. And then let's zoom in to get a closer look at the first iteration. So all you need to do is then to step through is by simply uh, dragging the slider upwards to 2. See that segment is added onto what existed as just the first iteration. So this was the first step. This add the second step. Simply once again hit the 3 and then drag down, and you'll see another addition. The 4, it's getting even larger. 5 was what we were previously seeing, and then you're able to go all the way up to 7 iterations for this preset. Uh, the reason that I decided to set cast for the number of iterations was because you see larger buffering issues whenever you're trying to work or generate these massive strings, which you can see I added a counter in the bottom right corner, which the 78,125 is equivalent to the number of branches used to generate this tree. So from the bottom, this looks small, but as you slowly zoom out, you can see simply how large this iteration is. So just by slowly zooming out, you can see how much of the tree there is that you can look at. Additionally, to visualize it, I add a debugger which will print each level of iterate that, or what the string is for each iteration, depending on the number of stars. So if this was the first iteration, then this is the string of the L system after going through the second iteration, the third, and then that for this one it'll be all the way up to the seventh, which you can see is a very large string. So here we have what was the first tree. I'll simply go through the drop down, which again, I decided to do a drop down rather than using hotkeys to iterate through just because I thought it would feel more natural for this UI. So by hitting the generate, in a few seconds, you'll see that this tree is generated, which is, again, from the examples given. This has 3,000, and then you're able to iterate all the way up to the 7th version, which I'm not going to do because it's just going to cause buffering issues. But if you want to try it out yourself, you're free to do so with the project, which I linked either at the beginning or at the bottom of the paper and or of this video. For tree C, hitting regenerate again creates this tree, again, which was pictured as before. Tree D generates this tree. Tree E, which is this one. And here is where I'm going to stop and show off some of the other editable uh, functions within this section of the GUI, just because it's easier to visualize for this one. So if you want to change to the rotation angle, that's something that you're able to iterate simply by dragging the values. You kind of shift whenever you're doing that. So if you just want to drop that to 0, so then you can just do whatever you want with the angle. So let's go here, and you can kind of see uh, how the rotation angle of the tree shifted to this 84 degrees. If you want to bring it down, you can kind of see during these quick iterations how the angles of the leaves are slowly rotating to match. And then similarly, what you can do is change the branch width and branch length of each of the generate pieces. So right now, if you go in, I guess you can't really see where the disconnects are. Actually, I will show these in one of the custom trees, which is coming up in a second, because it's easier to see. But going back, this is tree F, which is in the examples, which you can again kind of scroll in, and using these functions, you can control how quickly you zoom in and out, and then generating the different steps to each of these trees. Each of these I tested so that it would work, or the number of iterations would be slightly below 100,000 branches, just because, like I said, it could cause buffering issues. And I really like the way that you're able to drag around and inspect closely each of these kind of fine changes within these generations. And then something that you're also able to do, which I thought I should mention at this point, is you're able to manually make changes to what the starting axiom is, as well as the rules that exist within these presets. So say that I want to add an additional string. Let's do like fx, because those are some accepted values. By hitting the generate button, I drag the iteration up to the max value. So this may take a second to generate. Yeah, there you go. You can see that it kind of, but just by adding those, the reason why it took so long is, yeah, it generated over 100,000 branches. But just by making those changes, you can generate these types of systems uh, based off of what that original L system was that was given to you from the preset, and you're just able to go in and make these slight changes to generate these pieces, which, again, so this was actually a pretty cool form that was made. Additionally to that, there is the custom tree, which I added, which is additional to those 6 basic ones, which is the dragon curve, which you can see here in this example. And then this is probably a better one to show off the branch width and branch length. So things that you're able to do is, let's move the branch length up to, say, let's do 8. This will expand uh, or make the dragon curve a bit bigger, and you can see that each of these lines that are created to make these boxes uh, are a branch that is generated individually from this character chart. And then something which you're able to do is, I guess I should mention, the length is how long the lines are, which are rendered using line render, which is based in Unity. And then the branch width is, of course, the thickness of the lines. So if you want to move this up to, say, around 5.9, for curves like this, you can kind of fill what the object is. So if I want to move this all the way to the max, then yeah, it completely fills uh, the inside of the dragon curve. And if I want to move this to 14 and away in a couple seconds, you can see that it creates a new form in the 13th iteration. If I want to go all the way down to, say, 3, uh, here, this is where the dragon curve it hasn't really taken shape yet. It's kind of just a blob. So let's move this back down to, say, 1.6, sure. And then you can see that you can once again see what the curve is in the third iteration. Another example is going to custom tree 3, which was an example that I found on a website. Let's move this up to 1.4 should be good. Let's move that back down to 5 just to make it easier. And let's hit generate. This will take a few seconds just because it's the max iteration, but it should create a kind of, yeah, compressed tree, which has a whole lot of branches. That's kind of a cool system where it branches out very easily, and you can make the lines thicker again by simply hitting the branch width, and this should kind of fill in a lot of these areas and make the visualization uh, thicker, I guess, is is the way that you can see it. So there aren't as many holes within it. Visualization. This may take a couple seconds just because not only are we generating the 59,000, but again, you're having to load more space. So yeah, here you can see a lot of those gaps were filled in, and you can, so again, similarly, just slide all the way back down to one iteration, and then let's drag speed down. You can see it generates all the way down to one tree here. The third iteration, branch width. There you go. You can see this is generated. So another thing which I added was a custom mode. So what you want to do is if you want to scroll all the way down to the bottom to a custom, this is kind of just a blank test version where you can either uh, or where you can load in or enter in your own L systems. You were able to do that in the previous versions, like I showed earlier, where you can make edits to the rules and axioms, and this is this just gives you more freedom to do so. There's a difference, or there's iteration levels between 1 and 10, but this is supposed to be used, or you're just supposed to iterate slowly whenever using the custom version, just because, as I kind of mentioned and showed before, it's like once the generations get to above 100,000, then there start to be some latency issues, and or you may have to even restart the program entirely to get your computer running correctly. So let me move this down to, say, 3, just as an example to show that you can load uh, strings. I wanted to use this Strapinsky triangle, which I'm going to use the formula from Wikipedia to load. So here, it's important that you manually input this. You can't just kind of drag in like, or you can't just drag in the inputs because you can see that if you just simply drag this in, or this is what I converted the format to, it will not uh, accept this uh, formatting. You'll need to have this style formatting, which is slightly different. I'm not exactly sure why the input is different when you copy paste it, but it is. So usually what you need to do is go in and then make the manual entries. So here is the FFF, and then I believe there shouldn't be issues with this one just because I entered it and then it's similar formatting. Uh, and the 120, so let's move that all the way up. Okay, so let's generate the tree, the camera drag, let's zoom out, there we go. And as you can see here, it matches what this iteration looks like. So I guess here I should be going to 4, and it should match by scrolling out. Scrolling down, you can see that they are uh, the same generation, and you can go as far up as you want to for this one. But you can add by manually inputting your L systems, you should be able to correctly load whichever L systems that you want, which is depending on if your inputs are with the proper formatting, which uh, i- involves having these characters, which is the F and G characters, which are the same, which are used to generate the branches, the X and Z, which are kind of placeholders, the plus and minus, which are the for changing rotation angles, and then the brackets, which are used to both pop and push the current states from the stack and vice versa. Um, and then you have to make sure they're also, as I kind of mentioned before, matching this formatting to where the key value for the a singular rule and or dictionary, which is how they're stored, has the key value, which is just F, and then the string value, which is whatever the rule is, as the second parameter of the dictionary. So yeah, that is all that I have for this. I hope you enjoyed.